What's up you guys? So today I'll be doing this video with my friend Len with a high voice and me with a deep voice. So today we'll be talking about asymptotes and I hope you guys enjoy this video. So let's get into it. Number 1. Asymptotes. Asymptotes are lines that makes a curve approach both the negative and positive infinity. For example, the two red lines are asymptotes. The blue lines are the curves. The curves are approaching these two lines but are being forced to go to the negative and positive infinities and not touch the red line. There are 3 types of asymptotes: vertical asymptote, horizontal asymptote, and oblique asymptote. Number 2. Vertical asymptotes. They are lines that exist when the denominator of the rational function equals to 0. For example, this equation 7 over x minus 7 has a root of a denominator which is x minus 7. Hence, the equation for the vertical asymptote is x equals to 7, which is highlighted in blue. Number 3. Horizontal asymptotes. Horizontal asymptotes are lines that exist when the degree of the numerator is less than or equivalent to the degree of the denominator of a rational function. For example, this equation y equals 6x minus 7 over x. So 6x and x have the same degree, hence you can assume that y equals to m over n, which equals to 6. Therefore, the horizontal asymptote is y equals to 6, which is highlighted in orange. Lastly, oblique asymptotes. They are lines that exist as the quotient of a rational function if the numerator's degree is more than the denominator's degree. For example, this equation y equals to x squared minus 5x plus 4 over x minus 2. By performing long division, you'll be given the quotient x minus 3, which is the oblique asymptote. Hence, y equals x minus 3, which is highlighted in green.
Thank you, Len, for explaining the terminologies. It was nice. We are going to do steps taken to find the asymptote. Are you ready? You are. Okay, so number 1. The first asymptote that has been explained before is the vertical asymptote. So how do we find it? Well, it's simple. Find the root of the denominator of a rational function. For example, y equals to 40 over x minus 4 in brackets squared. This right here is what's going to determine the vertical asymptote, hence V dot A acronym. You have x plus 4 and x minus 4. Hence, the vertical asymptote would be x equals to 4 and x equals to negative 4. Simple. Second thing we're going to find is the horizontal asymptote. Now, in order to find the horizontal asymptote, we must look at the highest degrees of the numerator and denominator. Observe, y equals to 5x minus 4 over 3x. So you see 5x is the highest for the numerator and 3x is the only one. We use m and n to represent the degrees. So m is meant to represent the numerator's degrees and we use n to represent the denominator's degrees. So for example, y equals to 5x minus 4 over 3x. So this does contain an asymptote. But how do you tell? So option 1 is if m is more than n, then it equals to 0. 5x degree to the power of 1 and 3x to the power of 1. So therefore, these two degrees are equals to each other. Hence, option 2. If m equals to n, then y equals to the coefficients of those two degrees. So therefore, horizontal asymptote, headshot A dot acronym is y y equals to 5 over 3. And that's how you find the horizontal asymptote. The third thing we're going to find is the oblique asymptote. Now, following the same rules as the horizontal asymptote, we can only find an oblique asymptote if the numerator's degree is more than the denominator's degree. Then that is when y equals the quotient, which is the oblique asymptote. Since this is equals to x squared minus 2x plus 1 over x plus 1, we are going to find the quotient of this equation by performing long division. Therefore, oblique asymptote, which is O dot A, is y equals to x minus 3. So this here is a quotient, and this right here is the remainder. And that's it. And this is how you find oblique asymptote. So I'm going to explain how do you find an asymptote with a given graph. This is how you find the asymptotes with a given graph. So you can see right here, this graph has vertical asymptote and a horizontal asymptote. This graph right here has 2 vertical asymptotes and 1 horizontal asymptote. And this last graph right here has 1 horizontal asymptote and an oblique asymptote. Right here is the slope. I'll show you guys how to find the asymptotes with these 3 questions. So you guys can pause the video right here and solve these equations to find the asymptotes, or you can just wait for 5 seconds and I'll solve the equation. 5, 4, 3, 2, and I'm gonna do this. So, this equation, you see the roots, we see that this does not have any function at the top in the numerator, so that means this only has a denominator, hence there will be only a vertical asymptote. Hence, therefore, the vertical asymptote is x equals to 3 and x equals to -3. That's the first answer. Simple. On to the second question. As you can see here, this question's degree is higher than the denominators. If m is more than n, then y equals to quotient. So do long division with this equation. So this is your quotient. Hence, the oblique asymptote is y equals to x minus 1. Simple. Now, third question. And 2x squared is more than x, so therefore it's the same as this question right here. So if m is more than n, then y equals to quotient. So using long division, you only use long division when you find the quotient in this type of questions. Therefore, the oblique asymptote is y equals to x plus 3. Not only that, these 2 questions have a vertical asymptote. So this has a vertical asymptote of x equals to 2 because this is the vertical asymptote. And this right here is the vertical asymptote. So, yeah, thank you guys so much for watching, and I hope you guys have a wonderful day ahead. Bye bye!